Hello and what's up to you all awesome and wonderful matriculants. My name is Abram and I'm so excited, guys. This is our very first live broadcast and it's for you guys as matriculants this 2015. So I'm excited. It was your first day back at school. I hope you enjoyed it. Today's teacher is Mr. Lunga and we're doing mathematics. Lunga, how are you?
I'm very well, Avi. How are you?
I'm feeling so excited. You can tell, man. What are we doing today?
Right. Today we're going to be doing some trigonometry. We're looking at 2D and 3D problems.
Awesome stuff. Well, guys, you get the notes that Lunga will be working on. Simply go to our Facebook page, which is facebook.com/learnextra, or visit our lovely website, which is learn.mindset.co.za. You will notice that all the notes are extracted from this workbook. So if you're interested in getting this workbook, simply email sales@mindset.co.za or ask me on Facebook how to get it. Guys, it's possible. It has got all the answers that you could ever need. Otherwise, let's enjoy the show, guys. Take it over, Lunga.
Thanks, Abi. Right, grade 12s. As I said, we're doing 2D and 3D problems. Now, most of the stuff is stuff you've done in grade 11, all right? But in grade 12, we're taking it a step further in the sense that we're looking at 3D problems as well, okay? But then again, that should not stress you out. I'm hoping to shed some light on that. I'm going to guide you to how to make it look and sound a bit more simpler. All right, so let's go through our notes. Right, so here's a nice summary that's been prepared for you. Okay, we'll be looking at solving 2D problems. Okay, so we're looking at 2D problems using the sine rule, the cosine rule, as well as the area rules. Now, you should be very familiar with all of those, okay? Okay, let's look at when and how to use the sine rule. It says here the sine rule is used when the following is known in a triangle, which is not a right-angled triangle. Please take note that it is not for a right-angled triangle, all right? So, we use the sine rule when we are given two angles and a side. We also use the sine rule when we are given two sides and an angle. Very importantly, it's been done for you in brackets here, that the angle must not be included. What does that mean? It means that the angle must not be between the two sides. Let's explore that some more. Okay, if you look at this triangle here, right? Here is the rule, it's been given to you. Okay, let's look at the first format. It's where you have sine of the angle, okay? So that would be angle A divided by the side, and note that it's a corresponding side. So this angle must correspond to the side, or the angle must be opposite the sides, in other words, okay? Now that ratio is equal to sine of this angle or another angle over the corresponding side again, all right? We can also write that as, or say it is equal to the third ratio, which is, let's get a different color, sine of that angle divided by, again, the corresponding side. Okay, please take note that if we're talking about sine of angle A, we must be dividing by side opposite the angle A, all right? Conversely, we can look at the reciprocal of that and tip all that around. Okay, let's go down a bit. We can reciprocate all that if you want to. It's still the same, where it is now a side divided by sine of the corresponding angle, and we say that ratio is again equal to another side divided by sine of the opposite angle, and we say that that ratio is equal to another side divided by sine of the opposite angle. Okay, we'll be applying these in a few minutes. All right, but let's scroll down and see what else we need to know. Okay, here are some more notes. let's look at the cosine rule. Okay, so we're done with the sine rule now. Let's look at the cosine rule. The cosine rule is used when the following is known in a triangle, which is, again, not a right-angled triangle, not a right-angled triangle. So we use the cosine rule, very easy, when we are given 3 sides. So if you look at this triangle here, if you're given the length of C, the length of B, and the length of A, you can then apply the cosine rule. Or if you are given 2 sides and an included angle. So if you look at this obtuse angled triangle here, 2 sides, let's go for A and B, why not? And an included angle would be an angle in between, if you want to, between the 2 sides. That means we can use the cosine rule. We can learn that like a parrot if you want to. Why not? Right. Okay, and those are the 3 versions of the rule. Okay, let's look at it. So what does the rule say? It says that the one side squared, so the square of the one side is equal to the sum of the squares of the other 2 sides. Okay, so a squared is equal to b squared plus c squared. Okay, let's use a different color there. Plus c squared, all right, minus 2 multiplied by the product of these 2 sides, okay, and that is multiplied by the cos A or cosine A. Remember A, this angle A here, must be corresponding to this side there. All right. If you don't want to write this in terms of A squared, you can write it in terms of B squared. Why not? Then again, so if you go B squared, so we go B squared is equal to the sum of the other 2 sides now. So it's the sum of that side, sorry, the sum of the squares of that side and that side. And you are you're taking away 2 multiplied by the product of A and C, and that is multiplied by cos, again, of B, which is the angle corresponding to the angle we started off with. And the same applies if you want to write the cosine rule in terms of c squared. Let's look now at the 3rd rule, which is the area rule, which again you should have seen. The area rule is now used to find the area of any triangle. We're moving away from the easy primary school stuff, half base times height. We're given a formula, now a different formula. Okay, what does it say? What do we need to know in order to use this new formula? It says we can work out the area of of any triangle when we are given at least 2 sides. So we need at least 2 sides of the triangle, and very importantly, an included angle. And remember, included means between the 2 sides we are referring to. So let's look at our triangles. So as you can see, it can be an acute angle triangle or an obtuse angle triangle. It doesn't matter. Okay, so if I want to work out the area of triangle PQR, I need to know 2 sides. So this first format says half Q times R. So it's that side and that side. And we're multiplying that by the sine of the included angle. So now which angle is between the 2 sides? It is angle P. There it is. Or if you want to write this in terms of P and R, let's get a different color. We can say it is half of P multiplied by R multiplied by the sine of which angle, again, would be the included. It would be this one. Must be between the 2 sides. Or you can use a 3rd version where we're looking at sides P and Q and we are multiplying it by sine of the included angle, which would then be R automatically. All right, let's see if we can start applying these now. Here are some practice questions for you. I'd like you to try these with me at home, right? So, here's a problem here. it says a piece of land has the form of a quadrilateral. Remember, that means it's a four-sided shape. With A, B, C, D, that's the name of the quadrilateral. And they give us the dimensions of the sides of the quadrilateral. We're told that AB is 20, BC is 12 meters, and CD is 7 meters, which is there, and AD is at the bottom there is 28 meters. Okay, so this here is a rectangular piece of, it's a piece of land. It's in the shape of a quadrilateral. Right. It says the owner decides to divide the land into two plots by erecting a fence AC. So this line here going through the shape is our fence. Okay, so you need to see this in your head. Yes, this is a 3D problem, but it shouldn't be too much of a problem, guys, because you can look at it as as if we're right above it. Okay, we're looking down on this piece of land, and here is the fence. Okay, we are above it, right? And we are told that angle B, which is that corner there of the garden, or the plot, is equal to 110 degrees. All right, so let's see what they want us to calculate. It says calculate the length of the fence AC correct to 1 decimal place. Right, so we need to worry ourselves with the fence now. Again, let's just look at what we are given and think back to our introduction. Okay, when do we use the sine rule? When do we use the cos rule? And when do we use the area rule? Right, we are given the one side, AB, and we are given side, that's BC, and we are given side AB, and we're given an included angle. So can we use the sine rule here? No, we cannot, because we've got an included angle, so it makes sense for us to try using the cosine rule. Right, so what does the cosine rule say? If we want to work out AC, let's use brown. It will mean that AC squared is equal to the sum, remember, of the squares of the other two sides. So what are the other two sides? It will be BC squared and AB squared. So BC squared plus AB squared minus 2 multiplied by the sum of the two, 2 multiplied by the product of the two sides. So 2 times the length of BC, okay, I'm running out of space here, times AB, okay, and that is all multiplied by the cosine of the angle that is opposite the side we started off with. Okay, what is the angle that we started off with? 110. So multiplied by cos 110 degrees. All right, so let's now substitute. So AC squared will be equal to, how big is BC? Let's go up. BC is 12. So it'll be 12 squared plus AB squared, which is 20 squared, okay, minus 2 multiplied by the product of the two sides. So BC is 12 and AB will be 20. And that is multiplied by cos of 110 degrees. Right? So let's bring our calculators up. But remember, we don't want AC squared. We want AC. Okay, so there's our calculator. So we want the square root of that. So it'll be the square root of 12 squared plus 20 squared minus 2 multiplied by AC, so that'll be 12 times 20 cos of the angle is 110 degrees. Let's close that. And there's the answer. 26.61. So it'll mean that AC, if you find the square root of that, is now going to be 26.61. Oops, okay, that doesn't look right. Let's write that out properly. So 26.61, remember your units, it's going to be meters. So that is how long the fence is dividing the plot. So let's write that in, 26.61. Right, let's look at 1.2. It now says calculate the size of angle BAC, correct to the nearest degree. Okay, let's go back to our picture. Where is BAC? BAC is this little corner here of the plot. Okay, so let's look at what we have. We've got the three sides now, don't we? We've got BC, AB, and AC, and we've got that angle. Okay, so we can use the cosine rule. Can we use the sine rule? Let's see. They want us to find this angle. Do we have the corresponding side? Yes, we do. And we've got that angle. Do we have the corresponding side? Yes, we do. Okay, so here you get to choose. You can use the sine rule or the cosine rule, but I would go with the sine rule here. It should be easier. All right, less squaring, so less chances of you making a mistake. So let's go with the sine rule. Right, so 1.2. So it'll be sine of 110 divided by 26.61. So it's sine 110 degrees divided by 26.61 is equal to, they want us to work out that corner there, so it's going to be sine of A divided by 12. Sine of A, which is what we're looking for, divided by the corresponding side, which is 12. Now it's just a matter of first solving for sine A. Once we've solved for sine A, we can then work out what A is. Right, so if you want to write that now in terms of sine A, it means we need to multiply both sides by 12, so we can say sine A is equal to 12 multiplied by sine of 110 degrees divided by 26.61. Okay, and let's bring up our calculators. So let's clear that. So 12 sine 110, oops, 110 divided by 26.61. Okay, that gives us an error. Let's see what we've done wrong there. Okay, I'm going to ask you guys to work on this, all right, while I see while I went wrong during the ad break, and I'll see you again in 2 minutes.
Awesome.
Okay.
Awesome stuff, Lunga. Guys, make sure that you get your notes. They're uploaded on our Facebook page, and also follow us on Twitter at LearnExtra. See you straight after this break. Welcome back, awesome matriculants. Now, guys, we've got an exciting show for you guys. Apart from that, we've got an awesome competition that we're running, the Be a Bright Spark competition. All you need to do is to get yourself this awesome SafeWays K53 manual or download the cool Android app, which is available from Galaxy, Samsung Galaxy Play Store or the Google Play Store, guys. It's simple, 59 Rand. It gets you the app and you could win a Chevy Spark L. More details will be posted on our Facebook page. But now, Lung, I've got some comments from the Mindsetters. Nelile Nomani Kabasha saying, hi, AB, I'm watching. Thank you for watching. And other Mindsetters giving their answers to some of the questions that we're doing, such as Mapula. Hey, I'm watching and I'm hoping to learn more today. That's Mapula Muloto. Sina also saying they're watching. Thank you guys for watching, and let's help one another and also help other Mindsetters on the page. If you see someone struggling, be there. That's the team spirit that we want. Lunga?
Thanks, AB. Great stuff, guys. Okay, so that's what we should have as your answer. All right. So, AB, I'm going to need for you to help me memorize. So it's 0.423. All right. So it means that sine A is 0.423. Please call it
Correct.
out. Yeah. What's the rest?
You didn't give me the rest.
Did I not? Okay.
Sorry.
All right. 0.423, 762,
Yes?
174.
Okay.
0.423,
762
762,
174.
174. Okay, guys, it's important to keep all the digits and round off your answer only right at the end, because if you round off too early, you're moving further and further away from the actual value. All right, so now we've given the ratio, we want to work out the angle. Remember, we go shift sign now on our calculators. Okay, so it's going to be shift sine of, okay, let's clear it first. Shift sine, okay, AB, what was that number?
423
423
762
762
174.
174 74. Right, and there's our answer. Our answer is 25.1 degree. Right, so A is 25.1 degree.
Can I say this, Lunga?
Sure.
There's a mindset on the page that actually got it right. That's Yvonne Makaleni. Well done.
Well done, Yvonne. Okay, so it's good to see that a lot of you still remember the stuff from last year. Okay, let's see what else is asked from us. Right. Okay, so that's the same question. We're continuing 1.3 now. They say calculate the size of angle D correct to the nearest degree now. This rounding off. Nearest degree. So we're not going to have any numbers after the comma. Size of D. Where is D? D is this little corner here of our plot. Right. So remember we've got AC. It is 26.61. And we've worked out, what did we work out in the previous slide? We worked out angle A, which was 25.1. Right? So now they say calculate the size of this corner here. So let's see, what are we given? If you look at triangle ACD now, okay? It's very easy if you break it up, guys. These 3D problems, just break them up into 2D shapes, okay? And then just apply the area rule, the cosine rule, and the sine rule, and you should be fine. That makes it much simpler if you just break it up into stuff that you can, that makes it easier for you. Right, so if you look at triangle ABC, we've now got three sides. We've got BC, which is 12, we've got AB, which is 20, and we've got CA, which is 26.61 meters. Right, so if you think back to our notes at the beginning, this means we can use the cosine rule, can't we? All right. and they're asking us to work out angle D, which is this one here. Okay, so let's take it away. It means that AC squared, so this is 1.3 in pink, AC squared is equal to the sum of the squares of the other two sides. So AC squared will be equal to BC squared plus AB squared. So it will be BC squared. Wait, are we looking at the right triangle there? No, we're not. So it will be AC squared is equal to CD squared. I beg your pardon. We're looking at this lower triangle. Okay? Because this is the angle we need to worry ourselves with. Okay? So AC squared is equal to CD squared. Let's get rid of that. CD squared plus, what's the other side? AD squared. Okay, again, minus 2 multiplied by these two sides, so it's CD times AD, okay, multiplied by the cosine of the angle, which we are looking for, which happens to be D. Let's call it D. Okay, let's substitute numbers now. How long is AC? We said AC is 26,61. So it's 26,61 squared is equal to CD and AD. CD is 7 and AD is 28. 7 squared, 28 squared, minus 2 multiplied by 7 times 28. Okay, multiplied by cosine of this angle, which we do not know, which we're trying to work out. Right, so let's solve for cos D so that we can work out what D is. So it'll mean that if I take these two over to the other side, it means that 26,61 squared. Okay, let's make that look like a 6-1. 26,61 squared minus 7 squared minus 28 squared is equal to negative 2 multiplied by what we've got on the right-hand side multiplied by cos D. We're getting this slowly but surely. Right, I now need to divide both sides by this here. So it means that cosine of this angle is equal to all that 26,61 squared minus 7 squared minus 28 squared divided by, don't forget this, the sign, negative 2 times 7 times 28. Right, AB, I'm going to need for you to memorize or to write this down for me rather.
Okay, all right.
All right, let's bring up our calculator. Let's move over to this side. Okay, so it's going to be 26,61 26,61 squared minus 7 squared minus 28 squared, and we're dividing all that by negative 2 multiplied by 7 and multiplying that by 28. Right, that's what I need for you to memorize or write down for me. 0,318,642,602. All right, so it means, so that's 0,318
318
318
642
642
602.
602. That is equal to cos of the angle D. Okay? So now, how do we work out how big angle D is? We need to go shift cos. All right? So AB, I'm going to need your help again.
Okay.
So it means that, let's clear that, shift cos 0,
318
318
642
642
602.
602. And that's our answer, 71,4. Remember it said to the nearest degree, so that will be 71 degrees. So it means that angle D is equal to 71 degrees. Right. Let's look at the next question. Let's write that in there. It always helps to write the stuff in so you know what you've worked out. So what does 1.4 say? Calculate the area now of the entire piece of land A, B, C, D correct to 1 decimal place. Okay, let's think back to our area rule. Okay, it said the area of any triangle, okay, not a quadrilateral, it said a triangle. So it means we need to break our land up into triangles, which has been done for us. So we're going to work out the area of this triangle ABC, and we're going to add it to the area of that triangle ACD. Right. Let's do the top triangle. So it means that the area will be half of the product of two sides. So it will be 12 times 20. Okay, so it means that the area of the entire shape is half multiplied by 12 times, how long is the other side? 20. And that is all multiplied by sine of the included angle. How big is the angle between those two sides? 110. There it is, it's been given. Sine 110. Okay, and we're adding that. Okay, I'm going to write it below. We're adding that to the area of triangle ACD. Let's go with the 7 and the 28. Plus half times the 7 times the 28. And that is all multiplied by the included angle, which we worked out in the previous question, which happens to be 71. 71. And now it's just a matter of entering all that in our calculators. Right, so let's bring that up. Okay, so it's going to be a half, or 0,5, multiplied by 12, multiplied by 20, multiplied by sine of 110, and we are adding it to the bottom triangle, which is a half, or 0,5, multiplied by 7, multiplied by 28. Oops, I forgot a sign there. This would be sine 71. Let's just fix that, guys. Sine 71. Sine 71 equals, and that is how big our piece of land is, 205,42. So it's 205,42. Remember, it is area, so our unit must be squared. 205,42 meters squared. That is the total area of this piece of land. Let's move on to the next question, guys. Question 2. Okay. Again, it's a 3D problem, but again, do not worry. Just break it up into 2D shapes, or 2D figures, and apply either the sine rule or the cosine rule or the area rule. In the diagram below, AB is a straight line. Where is AB? So that's AB. It is a straight line. So it's that line there. And they say it is 1,500 meters long. Let's make that all yellow. And they say CD is a vertical tower. Okay, vertical meaning standing upright. Okay, up straight. DC is a vertical tower. Let's use blue for that. There's my tower. And they say, so that's DC, it is vertical, and they say it is 158 meters. And with C, A, and B, so the shaded stuff, C, A, and B, are points in the same horizontal plane. Horizontal meaning it's on the ground, okay? Lying flat, in other words. The angles of elevation of D from A and B are 25 degrees and theta. Elevation, remember, if you elevate something, you take it up, okay? So we're looking up. So it means that if I am standing, or if I am at the bottom at that point there, at A, all right, and I am looking up to the top of the tower, D, okay, the angle is 25. So that is how much I need to raise my eyes, 25 degrees. And the other bit says from B, so if I'm standing at this corner and I'm looking up to the top of the tower, which is D, the size of this angle is theta. And it says that CAB is 30 degrees. So this corner here, which is on the ground, is 30 degrees. Right, so what do they want us to work out? They say determine the length of AC. What is AC? Okay, AC is that bit there of the ground. Again, do not let the 3D stuff confuse you. Break it up again. Okay, so which triangle shall we look at? Let's look at the horizontal plane. Why not? We can look at the horizontal plane. This bit here that I'm outlining in purple. Okay, we can look at that, or we can look at this triangle here. Yes, it happens to be the side in a 3D picture, but if you take it out of this picture, it is actually a normal triangle, a 2D shape. All right, so if you need to work out this here, it means that we can use, we don't even need to use the sine and the cosine rule here. Remember these three rules? So sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent, right? So we are asked to work out AC. What are we given if you look at triangle ACD? We are given that angle, okay, and we are given the opposite side. And we are asked to work out the adjacent side. So we've got opposite, and we need to work out adjacent. So which one is opposite and adjacent? And it looks like it is tan. Right, so we're going to go tan of the 25. So this is 2.1 now. Tan 25 is equal to opposite. How long is the opposite side? 158. And we need to work out AC, which is the adjacent. I'm just going to write it as AC. That's very easy. It's just a matter of solving for AC. let's extend the page a bit. It means that AC is going to be equal to 158 divided by tan of 25 degrees. Right, allow me to write that on the right there. Let's bring up our calculators. Let's clear that. So it's going to be 158. We're dividing that by tan of 25 degrees. And what does that give us? Again, it's an error. What did we press wrong this time? 158 divided by, divided by tan 25. There, 338,83. 338,83. Remember the units, guys? It's all in meters. Right? And remember to write it in. So AC is 338,83. Super. Let's look at 2.2. What else do they want us to work out?
I think we should take a break, Lunga, and then we'll look at that after the break.
Great stuff. So I'll see you in a few minutes.
Cool, guys. Stay tuned, and if you still have some questions, feel free to throw them on facebook.com/learnextra. See you soon. Welcome back, awesome matriculants. Now we've got another exciting competition just for you guys. You're probably thinking that next year you need to go to varsity. Maybe you have applied, maybe you haven't, but I think you need to think about accommodation. So guys, all you need to do is to check out the competition that we have with South Point, because you could win 1 year's free accommodation. Enter right now. More information is on our Facebook page. Lunga, back to you.
Great. Thanks, AB. Right. So what is required of us? Let's continue with this question, guys. 2.2 says find the value of angle theta, which is this angle of elevation here. This one there. Right. Okay. If you look at the mark allocation there, it's 5 marks, okay, which means it's demanding a bit more from us. Why is it 5 marks? All right. Can we use these 3 ratios with the information we are given? No, we cannot, because we do not have enough information. So let's look at triangle BCD. So it's this triangle here, DCB, right? And we want to work out that angle there. The only thing we have there is the opposite side, which is 158 meters. So if I want to work out the angle of elevation, I need to do some more work, don't I? Okay, so we can either work out the hypotenuse of this right-angled triangle, DB, or we can work out side CB, okay? But it looks like it makes more sense for us to work out side CB, okay, because that is part of that horizontal plane. So how would we work out side CB first? Because if we have side CB, it would mean that we have the opposite angle and we have the adjacent angle, and we can again use tan. Right. So let's try and work out side CB now. Are we going to use the sine rule or the cosine rule? We can use, let's see, it depends on what we're given. We can actually use the sine rule. Okay, let's see. Okay, let's try the cosine rule rather, because we've got an included angle. So we've got the 2 sides and an included angle, so it means we can use the cosine rule, not the sine rule.
You can try use another pen, Lunga.
Mm-hmm. Which
the color, if you can just change the color of your pen.
Okay.
Maybe yellow, a more brighter color.
Or is it too dark now? All right. Okay, so if you're using the cosine rule, it means that BC squared Oh yeah, that looks better. Thanks, AB.
Yeah.
So BC squared is equal to the sum of the squares of the other two sides, which happen to be AC and AB. AC squared plus AB squared minus 2 multiplied by AB times AC, and that is all multiplied by cos of the angle in between, which is 30 degrees, cos of 30. Okay, let's do our substitution now. Okay, BC is 1 to 1 to work out. AC is 338,83. Okay. 338,83 all squared plus, how big is AB? AB is 1,500. 1,500 minus 2 multiplied by 338,83 multiplied by the 1,500 cos 30 degrees. Okay, and that will all give us how big BC squared is, but we don't want BC squared. Remember, we want BC, so we need to find the square root of all that. So let's bring up our calculators. So there's our square root. It's going to be 338,83 all squared plus 1,500 squared. Okay, let's just move that. Okay. Take away or minus 2 times 338,83 multiplied by the 1,500 cos of angle 30. One, 218,4. So it means that BC is equal to 1,218,4, and that is now going to be in meters. Right, so that's the answer to that question there, to BC, 1218. Let's just write it in. It helps if you write it in 1218,14. We haven't answered the question. They ask us to work out that angle of elevation theta. Okay, so now we've got the opposite side, which is 158, and we've got the adjacent side, which is 1,218, and it means that we can now use tan to work out the size of theta. Right, so if we extend our page a bit, it means that tan of theta is equal to the opposite, which we said is 158, divided by the adjacent, which is 1218,4, right? So if I want to work out how big the angle is, all I need to do is bring up the calculator again and go shift tan of that ratio. So 158 over 1218, comma 4. Okay, let's close that. Okay, let's just go and fix that quickly. Right, that should give us an answer. 7,38, so that is the size of angle theta. So it is 7,38 degrees. So that is how big that other angle of elevation is. Let's move right along. What else is required of us? 2.3 says calculate the area now of triangle ABC. So we're now looking at the horizontal plane, or the floor of this if you want to, and we need to work out the area. Now remember, if you want to work out the area, we said it is half multiplied by this product of two sides, and that is multiplied by the sine of the angle in between those two sides. Okay, so we've got side AB, which is 1,500. What else are we given, or what else have we calculated? In our previous question, we calculated BC, all right? But that's not going to help because we do not have this angle here, all right? However, this side here is going to help us, all right, because we've got the included angle. All right, so let's go with the 1,500 and the 338,83. Okay, so the area of that triangle is going to be a half times the 1,500 multiplied by the 338,83. Okay, and that is multiplied by sine of the included angle, which happens to be 30 degrees. 30 degrees. Okay, this is 2.3. Okay, up comes our calculator. So it's a half, or 0.5, multiplied by 1,500, multiplied by the 338,83, multiplied by sine 30. Okay, and it means that that is our answer. So it's 127,061. So it's 127,061. 127,061, comma 25. And remember, because it's area, it's going to be meters squared. Okay, so that is the size of the horizontal plane, which happens to be a triangle. Now they say calculate the size of ADB. So it's an angle ADB. Right. So I'm going to leave that with you to work out during the break. ADB happens to be this angle here. Okay? So see if you can work that out, and then I'll see you in a few minutes.
Unfortunately, that should be the last question. Well, the masters can work on it because we've run out of time.
Oh
That's
dear.
it. That's all the time we had for today's lesson. And I should encourage you guys that let's help one another. Make sure that you always have the notes. That's very key. Get our workbook. It has got all that we are working on. Order it. Just email sales@mindset.co.za. Otherwise, thank you so much, sir. That's where we have to end it. Guys, we love you, and we'll see you some other time. Peace.